Hello everybody and welcome to today's video. Today's lesson might be the last one for chapter 4, since chapter 4.4 in itself is just application questions as well as some realizations of the concepts that we have learned. Depending on the course load that you have, whether you're studying in a pandemic like we are right now or you're doing this in the future, your teacher might skip over chapter 4 entirely. They might go through it briefly, or maybe they'll go really in depth for it. If they do go in depth into chapter 4 and chapter 5, please let me know and I will make an additional video covering the in-depth concepts. But for now, let's just focus on chapter 4.3. So chapter 4.3 continues with the different differentiation rules for sinusoidal functions. So before we learned the simple ones like the sum rules, stuff like that, and now we have to apply the more difficult ones, including the chain rule, the product rule, etc. So again, as a little outline, we're going to go over all the remaining rules, and I'm just going to provide 2 very helpful tips for you to succeed in this chapter. So following the previous lesson, we have to learn the remaining derivative rules. So for these derivative rules, since they are complicated, I really recommend for you to try and split them up as much as possible to simpler functions. So if you're given a bunch of different terms, or if it's like something times something times something times something, you could probably take those different terms and put them as a separate function and then differentiate it by itself, and then combine it however you need to. So now that we have that, let's talk about the chain rule. That is the first one we need to discuss. Luckily for us, the chain rule is kind of simple when it comes to sinusoidal functions, and I'll explain why. So first of all, to just recall, we need to remember that the chain rule includes 2 different functions, right? The first function could be g of x. So you have something, and then you have your second function, which is y, and it is in terms of the previous function. So you would have f of g of x. That is what the chain rule is for. So if you have something of that format, you could apply the following rule, which takes the derivative of the inner part and times it by the derivative of the outer part. So if we're given something like this, so we have 2 times sine of pi x, we need to identify 2 different parts, which is the inner part and which is the outer part. Finding the inner part in sinusoidal functions is pretty easy because it'll always be accompanied after the sine or cosine, depending on what you're dealing with. So here, our inner function is pi of x, and our outer function is 2 sine of whatever, right? So this is what we have here. Instead of saying pi of x, I'm identifying it as x, just so we could have a simple function, right? And then h of x would be the inner part, which is right here. So now if we take the derivative of the other part, we get 2 times the derivative of sine x, so we get the derivative 2 cos x. Similarly here, we have pi and x gets removed, so we have the constant pi. Now to find f prime of x, we need to multiply the 2 derivatives together, and so we get 2 pi cos of x. So that was pretty simple. The rest are going to be a little bit more complicated. So first we have the power of a function rule. So what does this mean? Well, if you remember from the previous chapters, this means the following. So if f of x is differentiable, yeah, that definitely was how it said, we get the following expression. So the derivative of g of x to the power of n, I had f of x and g of x, let's fix that. There you go. So we have something g of x to the power of n, right? And we want to find the derivative of it. The way we would do that is we would first multiply by the power. So now we bring n to this side. Then we subtract 1 from the power, so we get this form right here. However, we're not done yet. What we need to do next is we need to multiply it by whatever in the brackets and find the derivative of it. So this is the full extent of what we need to know. Again, this is just a special case of the chain rule. So if you understand how we got this done, you should understand how we did this. Again, this is just an outer function of something to the power of n and an inner function of g of x. So now let's find the derivative of this here. So first we need to see that we have one term and two terms, okay? Then we also have cos to the power of 2 of x and sine to the power of 3 of x. So we'll have to apply this rule in both of the terms. So skipping to the actual derivative, it could be a little bit complicated, but let's take it step by step. So first, let's identify our inner functions. So our first inner function would be cos, and then we have it to the power of 2 times x, right? That's the same as cos x times cos x. So if we want to find the derivative of the outer function, we would take the 2 and put it in the front, right? So now we have 2 cos of x. Then what is our inner function? Well, our inner function would actually be the derivative of just cos x. Because remember, this format just means cos x squared. Hopefully my little diagram helped you out. So what's the derivative of cos x? Well, that is negative sine x, as we learned before. So now we have 3 times the derivative of the outer function times the derivative of the inner function. So that is term 1. We do the exact same thing here. So this time we have sine of x to the power of 3, right? So 3 gets carried over as a constant multiple. Then we decrease the power by 1, so we get a 2. So this is the derivative of the outer function. Then we're left with sine of x in our inner function. What's the derivative of sine of x? Well, it's cos of x. So now we're stuck with this right here. So what we should do now is open the brackets and try to simplify. So we know 3 times 2 is 6, and then we have a negative sine x, so we actually get negative 6 in the front. Then we'll just have cos of x and sine of x, which is right here. Next, we get 5 times 3, so negative 15, because you had a negative in front, and then sine of x and cos of x. You could say you're done there, but usually if you want to, you could try to see if you could simplify further, which is what we did here. We saw that there's sine of x and cos of x in both of the terms, so we take it out and we're left with this. In some cases, you might get a double angle formula. Remember from last math course you took from advanced functions, if you have 2 cos of x sine of x, that simplifies to sine of 2x. So sometimes you could do that. So hopefully you understood how we got to our derivative, which could be either one of these two, depending on what your teacher wants. So now for our last part, we have the product rule. So the product rule is a little bit tricky here, just because you could combine it as a term, right? Like, for example, if we had this substituted into this equation here, everything just got much more complicated. So we need to know how to deal with the simpler quote-unquote part first. So recall, if f of x and g of x are both differentiable, then the derivative of the product of these two functions is equals to the derivative of the first function times the original other function plus the original first function times the derivative of the second function. So if you remember this, then the rest just becomes your application. So here we are given the following function. So immediately let's define what g of x is and what f of x is. Since we have f of x defined in our question, we're just going to use h of x. So for g of x, let's use the first one, so we have cos 5 of x. And for the second one, we have sine squared of x. So now let's find the appropriate derivatives of both of these. Well, here we could define this as the chain rule, right? So we have an inner function of 5x and an outer function of cos of x. So the derivative of cos of x is negative sine x. The derivative of 5x is 5. Combine those two and you get negative 5 sine of x. The more you do these derivatives, the more quickly you could do them. Sometimes you'll be able to just look at this and say, oh, that's that. You won't even have to process how you got that answer. But for now, if you need to, you could show your work. So similarly for this one, we have to the power of 2, which is what we just learned right here, right? So we take 2 and carry it to the other side. Then we have to find the derivative of sine x, which would be cos x, and we also have sine x remaining. So we have 2 sine x cos x, which is also the double angle formula. So now that we have these two derivatives, we need to multiply them and add them in the following manner. So we get f prime of x is equals to the derivative of our first function, which is right here. Sorry, I forgot the 5x right there. 5x. Then we have the original function, which is right here, right? Then we have the addition of our second derivative times the original first function. So from here, you'll need to simplify. How do we simplify this? It seems very complicated. First, you need to remember that you can't just multiply sine 5x and sine squared x, since they have different inner parts, like 5x and x cannot be added together, for example. So the only thing that is actually in common would be sine of x, because this is sine of x squared and this is sine of x times the rest of the terms. So we could take that out. We could also see that we have a negative here and a positive there, so it'd be easier for us to just take out the negative from this part, and so we're left with negative sine of x. Now we need to see whatever is left in the other brackets. Here we haven't removed anything, so we still have 5 sine 5 of x, right? Because the only thing we took was the negative from the 5. Then we have the sine squared of x, where we took a sine of x from, so it's just left with a single sine of x. Now we move on to this part. We had a positive 2, we took out a negative, so now we have a negative 2. We had a sine of x, we took it out, now there's nothing left, so we don't write it. Now we're only left with cos of x and cos 5 of x. Again, you can't add these x and 5x together. That's not how this works. This actually changed the period of the function, so adding them together would not make sense. So this is our final answer. You could also probably leave it as this, depending on how your teacher wants it. So now that we have dealt with all the rules you need to know for this chapter, here's just 2 little notes that I want you to make sure you know. So for a test, for example, for a very complicated thinking question, you might have a combination of all of these 3. As you could see here, we went from the chain rule, which was simple, to the power of a function rule, which was the same thing as the chain rule, but now we also get powers within the equations. Then we went from there to also include the power rule, the product rule. So now it got even more complex. So your teacher might just combine all of these together, and in order for you to know how to deal with them, you'll need to, first of all, practice a lot, but you'll also need to split everything up into small segments. You cannot just look at this and try to find the derivative without figuring out this could be one function, this could be another, this could be expressed as 2 functions, this could be expressed as 2 functions, so now we have to find the derivative of 4 functions instead of 1. If you look at it that way, you'll get to your very basic terms, for example, cos of x, x to the power of 2, pi of x, and that is very easy to do at our current level. But if you look at something like this and just try to do it off your head, you won't be able to do it. so don't even try. Lastly, you should really learn how to apply these rules individually. It might look like you are struggling right now with power of a function rule. So that means you need to just study up on the chain rule more. You need to master the chain rule before you move on. Similarly, if you go to the product rule of sinusoidal functions, you should have already known how to do these two very, very well, because now you have to combine everything you know. So it'll always help you if you do all the questions. I've assigned 4 or even 3 questions in our textbook today, but doing them will immediately help you understand these concepts better. Question 8 actually asks you to find the tangent, the slope of the tangent that lies to the graph that you're given. So remember what we did in last class, find the derivative and find the slope. Then from the slope, plug it into y is equals to mx plus b, solve for b, and you'll get your equation for the line. Now that we have finished chapter 4, essentially, we're not counting chapter 4.4, we'll be moving on to chapter 5, so we could finish everything up there. Chapter 5 might also be a little bit more condensed because I've heard a lot of students, especially in the quadmesters, are moving on to vectors right now, and vectors are quite complicated, essentially, especially if you didn't take physics, physics 11 or physics 12, since it introduces a lot of new material. So hopefully we'll get to that soon. Again, I'd like to thank anyone who's stuck around for this long. You guys are truly amazing, and I can't wait to teach you guys next time. Bye bye!